morning, friends. Saraswati Namastubyam Vande Kamurupini Vidyanamam Karishyami Siddhirgopiniska. Hello, friends. I'm Mrs. Suneeta Udgave. We'll have engineering mechanics today. Then, why we are going to learn the engineering mechanics? Where are the applications in our day-to-day life activity? Can you please suggest? Yes, it is pulley mechanism. Where we adopt pulley mechanism? It is at the lift, is it? Then belt conveyor system. When we see the belt conveyor system, yes, belt conveyor system in atta chakki, yes, in RMC plants. What is RMC plant? RMC. It is ready mix concrete. Okay. Suppose we have to cast a broad slab for suppose a multi-purpose wall, then we will go for RMC. That is ready mix concrete. From market or from particular plant, we are demanding that particular suppose M20 grade concrete or M15 grade concrete. So it will be more beneficial and accuracy will be correct. So in that case, RMC plant, particular bags of cement or the gravels, they are conveyed from one place to another place, that is by belt conveyor system. Also we see it in our attachment. Okay. Then we will go for jeep crane or crane mechanism. Where we see the crane mechanism, yes, to lift various heavy materials from one place and to lift other. Well, using jeep crane or the gantry girder system is also there. Just as section, as like the structure is there, and the heavy materials you are lifting from one place and you are dropping to the other place. For that, you are adopting particular system. So that's why we are going for engineering mechanics. One of the example of centroid is, yes, centroid. How can you define centroid? Centroid is nothing but center of any geometrical figure, and every figure is having only one and only one centroid. Suppose we'll go for centroid of circle. It is located at the center from distance r from the periphery of the circle, is it? Then when we adopt the centroid, what are the applications? Can anybody suggest? Yes, stand off your vehicle. Then we see the seesaw mechanism. It is balancing system. That's why we are going for engineering mechanics. Today we'll introduction of centroid. We'll see various centroids of geometrical figures and then we'll have examples on it.
Now we'll see centroids of various geometrical figures. This is a rectangle of breadth b and depth d. Then its area will be breadth into depth. X coordinate will be half of the base and y coordinate from the x axis is d by 2. Okay. This is a triangle. For triangle, the area of triangle is given by half base into height, and the x coordinate will be b by 2 and the y coordinate from this x axis you are locating, it is h by 3. For right angle triangle, the same area, half base into height, the x coordinate will be b by 3 and y coordinate is same as h by 3. This is a trapezium of base b and top base as a, height as h. Then its centroid. For centroid, the area of trapezium is given by 1 by 2 h into bracket the summation of all two parallel sides, that is a plus b. The x coordinate is b by 2, half of the base, and the y coordinate is h by 3 into bracket 2a plus b divided by a plus b. For circle, the area of circle is given by pi r square or pi d square by 4. The periphery of circle, can you please suggest? The periphery of circle is given by 2 pi r. Okay. Then the x coordinate is obviously same. It is located at r, radius of the circle, and obviously y coordinate will be r. This is a semicircle of radius r. The area of semicircle is given by obviously half of the circle pi r square by 2 or pi d square by 8. Then x coordinate will be located at r distance and y coordinate is 4r by 3 pi. For quarter circle, the area is given by pi r square by 4. The x coordinate is 4r by 3 pi and the same y coordinate as 4r by 3 pi. Then we will see the example based on to calculate centroid of any geometrical figures. The numerical is find the centroid of given unequal angle, that is L section. So what are the steps to locate the centroid? The first step is just bifurcate the given figure into number of simple geometrical figures. So this is the L section, just bifurcate into this. Yes, first rectangle, then second rectangle. Okay. The step number 2 is just put the given figure into first quadrant. What are the quadrants? Yes, is it not a quadrant? This is the first quadrant, second quadrant, third quadrant and fourth quadrant. Just locate the x-axis and y-axis. The leftmost part will be your y-axis and the bottommost part will be your x-axis. Okay, then already we have bifurcated the location for centroid. We have one formula. For x bar, it is a1x1 plus a2x2 plus a3x3 and so on divided by a1 plus a2 plus a3. Suppose there are only 3 components, then this formula will work on. Otherwise, there are such 2 components. We are concerned about only a1x1 plus a2x2 divided by a1 plus a2. The formula to locate y bar is equal to a1y1 plus a2y2 plus a3y3 and so on divided by a1 plus a2 plus a3 and so on. Okay. So first of all, we have to calculate a1, a2, a3 concerned areas of the simple geometrical figures. Then we'll locate concerned x1 bar, y1 bar, x2 bar, y2 bar, and then we'll put all the values in this formula and we'll calculate x bar and y bar. So for that, you may have one table as like this. Into this, just first part or first rectangle as 150 by 12. This is the x bar distance and y bar distance, and the next component will be your area. So 150 by 12 is your rectangle. So tell me area of 150 by 12. What is calculation? Just tell me the calculation. 1800. Okay. Then we want to calculate x bar and y bar. As we learned previously, the centroid of rectangle is located so is it not the center of this rectangle? But we are concerned from x axis and y axis, is it? So it is located here, suppose x1 comma y1. So from x axis it is located at 188 plus, yes. So this total distance becomes 188. Is it? The total height is 200 mm and the thickness of this rectangle is 12. That's why this height becomes 188. So the x component will be half of 150 and the y component will be 188 this distance plus half of 12. Is it? So the x component will be half of 150 divided by 2, that is 75, and the y component we are measuring from concern x axis. It is obviously 188 plus half of 12. Okay. So 188 plus half of 12. Tell me this value. Yes? It becomes, is it 194? Yes, it's 194 mm. So the centroid of this first rectangle will become as like 75 comma 194. Then the second part is to locate the centroid of this second rectangle. The dimension of second rectangle is 188 mm by 12. So the area becomes, second rectangle is concerned as like this, of dimension 188 by 12. So tell me the area of this rectangle. 188 by 12. What is the calculation? 2256 mm square. Then we are concerned about x component and y component. The obviously x component we are measuring from y axis. So it is obviously we are measuring from this vertical x axis, this vertical y axis. So it is half of 12. So it becomes x bar will be half of 12. It becomes 6 mm. Is it? Then we are concerned about y component. The y component measuring from x axis. So the height of this rectangle is 188. That's why it is half of 188. 188 divided by 2. It becomes 94. Okay. So the centroid of, just I am locating by other pen, the centroid of this rectangle will become, yes, it is 6 by 94. Now we will go for locate the centroid of whole figure. These are the centroid of individual figures, but we have to locate centroid of whole L section. That's why we have to go for x bar is equal to a1x1 plus a2x2 divided by a1 plus a2, and y bar is equal to a1y1 plus a2y2 divided by a1 plus a2. So we are having formula x bar is equal to a1x1 plus a2x2 divided by a1 plus a2, and y bar is equal to a1y1 plus a2y2 divided by a1 plus a2. Just put the values and tell me value of x bar and y bar. What is the value of x bar?
36.62.
Okay, 36.62. The unit will be in mm. Tell me value of y bar.
138.37.
138.37 mm. Good. Lastly, what you have to do? Again, you have to draw the diagram and locate the centroid in it. Alright? Just as like this. This is your centroid from y axis and from x axis. So this is your CG of whole figure. Okay. So what are these components? 36.62, comma 138.37 mm. Okay.